Hello my dear students, today we'll take one more example on Euler's formula or Euler's theory. At the section 150 mm by 120 mm by 20 mm is used as a strut of 4 meter long with hinged at its both ends. Calculate the crippling load if Young's modulus for the material be 200 GPa. So the size of the T section is given, that is 150 mm by 120 mm by 20 mm, and length is 4 meter, so you can convert into millimeters, so 4 into 10 raised to 3 mm, and Young's modulus is 200 GPa or 200 into 10 raised to 3 Newton per millimeter square. So what you have to calculate here I is not given. Euler's formula, what it says, P is equal to pi square EI divided by LE square. So here E is given, L is given, I is not given. So you have to calculate I. How you can calculate I for the T section? I is given by I is equal to BD cube divided by 12 plus A into Y square. So this is the formula to find I. Okay, for this you have to calculate Y. Y is what? That is the position of the centroid. Okay, so you have to calculate first what is the position of the neutral axis. So let us see, this is the given T section. Okay, this is flange and this is web. Okay, this total overall depth is given here, that breadth is 150 and height depth is 120 and thickness is 20 mm. Okay, so flange size is now 150 into 20, thickness is 20, and web size is only this size. Okay, that is from here, this is the web size, here to here, this is web size, that is 100 into this total 120, so this is 20, so 120 minus 20, that is 100, so web size is 100 into this 20. Okay, first you have to find the position of the neutral axis. For that, I think all of you know that formula, y bar is equal to a1 y1 plus a2 y2 divided by a1 plus a2. For this you have to calculate what is y1 and what is y2. How you can calculate? Let us take, this is the section 1. Okay, this is section 1 and this is for the other section. So let us calculate first area of this web. What is that? Area B into D, this rectangular section. So B into D, that is B is 20 and D is 100. Okay, 2000 mm square. Now what is y1? So y1 means it is the distance from the centroid to the neutral axis. Here, where is the neutral axis? We don't know. So let us assume the neutral axis is at the bottom. Okay, this is just one assumption to calculate the actual position of the neutral axis. So now this is the position of the neutral axis. So y1 is distance from the centroid to the neutral axis. What is the distance from the centroid means? What is the centroid of this section? This is a rectangular section, so center of gravity exactly lies at the center. So 100 divided by 2, that is 50. So center of gravity somewhere here it lies. So the y1 is distance from the centroid to the neutral axis. So this is our neutral axis now. So this is y1, that is 100 divided by 2 is equal to 50 mm. Next, go to the flange. What is the size? Size is area. You have to calculate first. Area is A2 is 150 B into D, that is 20. Area, again this is a rectangle section. So B into D, 150 into 20. Now again you have to calculate what is Y2. Y2 is distance from the CG to the neutral axis. Where is the neutral axis now? The neutral axis lies at a okay, this is the neutral axis. Suppose this is the location. Okay, distance y2 is distance from the centroid to the neutral axis. Okay, the neutral axis is here. Okay, so distance from here to here, what is the distance? Till here to here, this distance is total, this is 20 divided by 2 is 10. So till here this is 10, 10 plus this distance, that is 100. So 110, or total distance is 120, total depth. You have to deduct this this here. You have to deduct this portion, that is 20 divided by 2, 10. So 120 minus 10, that is equal to 110. So any method you can use, either this 120 minus this 10, or distance from here to here, that is this distance is 10 plus this distance is 100, 110. So now you know what is A1, Y1, what is A2, Y2. So you can calculate what is y bar, actual position of the neutral axis, that is equal to A1 Y1 plus A2 Y2 divided by A1 plus A2. A1 you have calculated, that is 2000, into Y1 is 50 here, this is, and A2 is 3000 into 110. Okay, so 3000 into 110 divided by A1 is 2000 and A2 is 3000. So you get, when you calculate, simplify this, you get 86 mm. So this 86 mm, that is from the bottom. Okay, whatever you have calculated, you have considered bottom axis as the reference. So this is from the bottom. YB. Now you can calculate what is moment of inertia, Ixx. What is Ixx? Ixx is BD cube divided by I is equal to, for the T section, you have to use this formula, BD cube divided by 12 plus A into Y square. Okay, this is the formula. Here there are two sections are there, so you have to use this formula 2 times. Okay, now see, I will shown here 86, that is YB. From the bottom this is 86 and from top this is 34. Okay, here to here this distance is 34, neutral axis. Okay, from the neutral axis to the this topmost extreme fiber, that is 34 mm, and this is here to here, that is 86 mm. Now you have to calculate, you have to see what is y here. Okay, let us write this equation for the first section, that is here this web 20, B is 20 into D cube. D is this depth, that is 100, right? This is 100. Okay, this is full is 120, but this depth is 100. So B is this 20. So 20 into 100 cube divided by 12 plus AY square. What is area? Area is already calculated, that is 2000 into, now y. What is y here? The distance from the centroid to the neutral axis. Now this is the actual neutral axis. This is the position of the actual neutral axis, that is at a distance of 86 from the bottom and 34 from the top. Okay, now distance y CG is here for this section, right? Somewhere here, because total it is 100, so 50. It lies at a distance of 50. Now y is distance from the neutral axis to the CG, that is y1. Okay, that is y for the first section. Now you have to consider separately for the two section. So this is for the first section. So where it lies now, distance from here to here, total distance is 86. 86 minus 50, that is 36. This is how it is. Total it is 86 minus, you have to center of gravity of the rectangular section, that is divided by 2, that is equal to 36. Okay, always you remember y is equal to distance from the centroid to the neutral axis, that you have to remember. Okay, now this is done, this section. Then we'll go to the next section, flange. So again use the same formula, BD cube divided by 12 plus AY square. Now what is B here? B is 150 and D is 20. This thickness is 20. Cube divided divided by 12 plus ay square. What is a? A is 3000. First only I have calculated, and y. Now again y. What is that y? The center of gravity somewhere here. It is for the rectangular section. Distance from here to here, that you have to calculate. What is the distance? That is this y. Okay, this is for the section 1 and this is for the section 2. If what is this distance here? See, total this is 34, right? 34. You want distance from here to here. So this is center of gravity, means this lies at a distance of 10 meter. So 34 minus 10, that is equal to 24. So how you get this? That is 34 total minus 20 divided by 2, that is 10. Okay, so because the y is distance from CG to the neutral axis, this distance you want, that distance is total is 34 minus deduct this, that is 10, so you get 24. So simplify this, you get 6.09 into 10 raised to 6. This is Ixx. In this T section you have to calculate Iyy also. Only circular section Ixx is equal to Iyy. But how to calculate Iyy? You have that formula b1 cube b cube d divided by 12, that is the Iyy. Okay, now you have to consider y as the reference line and you have to write. Okay, now two sections are there, therefore I have written b1 cube d1 divided by 12 plus bt cube d2 divided by 12. Now write what is b1 for the first section. b1 is breadth, that is b into, b is 20, b is 20, breadth is 20, b cube 20 cube into d is 100 divided by 12 plus second b2 is 150 cube into d is 20. Okay, divided by 12, you get 5.69 into 10 raised to 6. Since Iyy is less than Ixx, therefore the column will tend to buckle in yy direction. Therefore, we have to consider the value of I as Iyy, that is 5.69 into 10 raised to 6 mm4. Okay, so lesser value you have to consider, that is Iyy 5.69. Here it is 6.09, so this is lesser value. So I is equal to 5.69 into 10 raised to 6 mm4. Now you can use the formula, but here what is LE? Now hinged at its both the ends. So LE is equal to L. So that is same. L is equal to 4 into 10 raised to 3. Now use the formula. PE is equal to pi square EI divided by LE square. Pi square E is 200 into 10 raised to 3 into I is lesser value 5.69 into 10 raised to 6 divided by LE 4 into 10 raised to 3 whole square is equal to 702. You will get, when you simplify, into 10 raised to 3 Newton or 702 kilonewton. Like this, you can calculate Euler's crippling load. Main thing in the T section, you have to find I. How you can find I? You should know the formula BD cube divided by 12 plus AY square. For that, you required Y. So Y is, so you have to locate, find that Y. For that, first you have to locate the position of the neutral axis. How you can find the neutral axis? You have the formula a1 y1 plus a2 y2 divided by a1 plus a2. So first you have to assume one reference axis either at the top or bottom. Any side is fine. If you consider at the top, what you get the answer, that is yt. Okay, I have considered at the bottom, from the bottom. So whatever the answer I get, that is from the bottom. Okay, so I hope all of you understood. If you have any difficulties, we can discuss in the class.